In this hands-on lab, we are going to get started with understanding of Google Kubernetes engine. Before we start, I'm going to briefly mention you the overview of this video. So we are going to get started with understanding of Google Kubernetes engine, GKE. After that, we are going to deep dive into the features of Kubernetes on Google Cloud. Next, we'll talk about Kubernetes versions and features. We will also learn about how to work on with GKE workloads. I'm going to include one of the most essential concepts in GKE, autopilot and standard modes. And I'm going to summarize the whole concept at the end. So let's start with understanding of Google Kubernetes Engine, GKE. Google Kubernetes Engine provides a managed environment for deploying, managing, and scaling your containerized applications. The GKE environment consists of multiple machines, specifically compute engine instances, grouped together to form a cluster. As you remember, in our previous videos, we learned how to work with Google Compute Engine VM instances. So these VM instances in GKE environment grouped together to form a cluster. GKE clusters are powered by the Kubernetes open source cluster management system. Kubernetes also provides the mechanisms through which you interact with your cluster. You can use Kubernetes commands and resources to deploy and manage your applications, perform administration tasks, set policies, and monitor the health of your deployed workloads. Now let's talk about some of the features of Google Cloud. GKE provides advanced cluster management features, including Google Cloud's load balancing for compute engine instances. GKE also provides node pools to designate subsets of nodes within a cluster for additional flexibility. Furthermore, GKE also provides automatic scaling of your cluster's node instance count. You can also see automatic upgrades for your cluster's node software. GKE also provides node auto repair, which means to maintain the node health and availability. You can also see that Google Kubernetes Engine provides logging and monitoring features with Google Cloud Operations Suite for visibility into your cluster. Now, let's start learning about Kubernetes versions and features. GKE cluster control planes are automatically upgraded to run new versions of Kubernetes as those versions become stable. So you can take advantage of newer features from the open source Kubernetes project. New features in Kubernetes are listed as alpha, beta, or stable, depending upon their status in development. In most cases, Kubernetes features that are listed as beta or stable are included with GKE. Kubernetes alpha features are available in special GKE alpha clusters. Now, let's understand about GKE workloads. GKE works with containerized applications. There are applications packaged into platform-independent, isolated user space instances, for example, by using Docker. In GKE and Kubernetes, these containers, whether for applications or batch jobs, are collectively called workloads. Before you deploy a workload on GKE cluster, you must first package the workload into a container. In GKE version 1.24 and later, Docker cannot manage the lifecycle of containers running on GKE nodes. Let's talk about one of the essential concepts in GKE. When you are creating a GKE, you'll have two options, autopilot and standard. Autopilot and standard. Let's start with understanding of what is autopilot. Autopilot basically manages the entire cluster and node infrastructure for you. Autopilot also provides hands-off Kubernetes experience so that you can focus on your workloads and only pay for the resources required to run your applications. Apart from this, autopilot clusters are pre-configured with an optimized cluster configuration that is ready for production workloads. Now let's move on to standard mode. Standard mode provides you with a node configuration flexibility and full control over managing your clusters and node infrastructure. In addition, for clusters created using the standard mode, you determine the configurations needed for your production workloads and you pay for the nodes that you use. So these are the essential concepts and the features in Google Kubernetes engine. So if you go to the official Google Cloud documentation, you will see lots of information related to GKE. So I would highly recommend you to go through the documentation. In the next video, we are going to work on our hands-on skills in GKE. So see you in the next video. Welcome back everyone. In this hands-on lab, we are going to learn how to create GKE clusters in both autopilot and standard mode. And we'll also learn how to connect to these clusters in Google Cloud Console. So let's go to the navigation menu. In upper menu, you can see navigation menu, and let's go to Kubernetes engine, clusters. And as you can see, containers, packaged applications, so it can easily be deployed to run its own isolated environment. Containers are run Kubernetes clusters. So basically I'm using my Quick Labs account, as you can see, because I have some problems with my own Google Cloud Platform account. So you can basically use your GCP account and you can create a new project for this Kubernetes project. Let's say you can name it my Kubernetes project, and you can work on that. But in my case, I'm working with Kubernetes with Quick Labs. So what we can do, we can click on create button, and when you create, you can see we have two modes, autopilot and standard. And as you remember, in our previous step, we talked about deep dive into these modes, but let's repeat again. So autopilot mode, basically the Google manages your cluster and it's recommended, and you can see it's a pay per pod Kubernetes cluster where GKE manages your nodes with minimal configuration required. However, standard is where you manage your cluster, a pay per node Kubernetes cluster where you configure and manage your nodes. So you can see that the autopilot mode is recommended for production. So what we can do, we can start on creating the standard mode. Let's click on create, configure. You can see the first thing is to give the name for the cluster. So let's give it, for example, standard cluster from console. So the next thing is a location type. You can choose either zonal or regional. You can see here the list of zone. You can choose based on your preference. So I'm going to continue with default US Central 1C. If you want, you can specify the default node locations. If you click on that, you will see the list of, you can see the zones. You can also see the control plane version. We have two versions, static version and release channel. So let's go with the default, the release channel, because it lets GKE automatically manage the cluster control plane version. However, static version manually manage the version upgrades. So you can also see the release channel here. You can select the rapid channel or stable channel, but default is regular channel. You can also select the version. At the time of recording, you can see these versions, but the default is 1.24.7. We are continuing with that. If you see here on the left, you can see the node pools. If you click on default node pool, you can see we have a default node pool, and we have a 3 number of nodes. You can change the size. If you want, you can make it more. So you can also see the search upgrade, and you can configure the maximum search and maximum available. If you want, you can also use a blue-green upgrade. This is a new feature. As you can see, it reduces the risk for workloads that are sensitive to disruptions. However, search upgrade is faster and more like cost effective for stable workloads. That's why we are going to continue with that. If you move here, you can see the nodes. You can add a nodes pool. You can also use a setup guide. You can see that we are using the image type. We are using the container optimized OS with containerized. So you can see you can select this image type and use Ubuntu or different operating systems. We can also configure machine configuration, like we can change the series or machine type. We can also change the boot disk type or boot disk size. You can also play with boot disk encryption. We have a Google managed encryption and customer managed encryption key. That is, the Google managed encryption key is no configuration required. Everything will made by Google. Customer managed encryption key, basically you manage the Google Cloud Key Management Service, managed by Google Cloud Management Service. So if you move on to networking, you can see the node networking. You can see the maximum pods per node. You can also see the security, where you can configure the service account, but here the default is compute engine default service account. If you move on to metadata, you can add Kubernetes labels by clicking this button. You can also add node tains. What is node tains? Basically, node tains lets you mark the node so that scheduler avoids or prevents using it for certain pods. So node tains can be used with tolerations to ensure the pods are not scheduled onto inappropriate nodes. So you can click on add node or add taint. You can also configure the GKE instance metadata. You can see the key value. Let's move on to the cluster. We have automation. We can see we can configure auto-scaling. Inside the networking, we can change the network if we have, but we are going to use the default network. We can also configure node subnet. We can also see the security, metadata, and features, other features of GKE. So we are going to leave all the default configuration and click on create. Creating GKE clusters will take about 10 minutes, between 5 to 10 minutes, so it will take a long. So whilst creating a standard cluster from console, let me show you how you can create a GKE cluster in autopilot mode. Let's click again, and you can see the standard and the autopilot mode, and here you can see there are some comparisons here. You can see nicely well structured, explain it. You can see the scaling, nodes, configuration, workloads, and supported. So try to understand between these two modes, because these are really essential. For example, if you are preparing for IC certification or Google Cloud Professional certification, understanding these two modes and differentiating between these two modes is really important. As far as I know, in my ICE certification, there were a lot of questions related to GKE. So you can see autopilot mode is designed optimized Kubernetes cluster with hands-off experience. However, standard mode is Kubernetes cluster with node configuration flexibility. You can see the scaling for autopilot mode automatic based on workload. However, standard mode you configure scaling. So we can pause the video and read more about this. So let's create an autopilot mode. So I'm going to give the name autopilot. I'm going to say that autopilot cluster from console, and you can configure the region. You can see I'm going to continue with US Central 1, but here you can also define application communication, the cluster by networking. You can use the network. You can have a public cluster or private cluster. So you can choose a public cluster to configure access from public networks to the cluster's workload. However, you can choose a private cluster to assign internal IP addresses to pods and nodes. So you can go to advanced settings, and you can see the automation, access service page, security, and metadata. You can also change the release channel. We can also go to review and create. Here you can see the cluster basics, networking, and advanced settings. So let's click on create. This will create GKE cluster in autopilot mode. So as I have just mentioned that creating the clusters will take a long time. So let's take a break, and in the next video we are going to learn how to create a deployment and service in GKE. So see you in the next video. Hey everyone, in this video we are going to play with GKE clusters, both autopilot and standard. As you can see, it took about 10 minutes to complete these GKE clusters. You can see the green check, which means it's ready now. You can see the name, location, mode, number of nodes, total CPU, total memory. And you can see we don't see the total CPU and total memory for autopilot mode because it will take some time to update it. So you have to wait a bit. So let's explore the standard cluster from console now. As you can see inside, you can see the details about cluster basics, automation, networking. You can see the security, metadata, and the features. You can see the nodes here. You can see the default pool. You can also see the nodes. We have 3 nodes. You can see the status, it's ready. You can see the CPU requested, CPU allocation, memory requested, memory allocatable, and storage requested. You can also edit it. You can see you can also add a node pool. You can deploy, you can connect, you can duplicate. So we'll see how to connect it soon. You can also move to storage, and you can see the storage classes. You can also see observability and logs. Let's go back. So with this standard cluster, you can add node pool, you can deploy and connect. Soon we will see how to connect to the cluster, but let me show you the autopilot mode as well. You can see we have autopilot cluster. So inside that you can see the details about the cluster. You can see the storage and observability, logs. You can also add it. You can see you can click on add it. You can also delete, deploy, connect. So let's see how to connect to the cluster. To connect to the cluster, you can click on 3 dots here, and you can click on connect, and you will see that it will suggest you the command line access. You can see gcloud container clusters, get credential, standard cluster from console. You can see it's specifying zone and project. So let's copy this and let's activate the Cloud Shell. So if you're using your Google Cloud Platform account, the first thing is you have to run is gcloud. Here, as you can see, it suggests it's gcloud config set project, and you can see you can take your project here. You can take your project ID, and you have to run gcloud config set project and project ID. And after that, we can copy and paste the command to connect to the cluster. I need to copy again. Let's go to click the 3 dots and connect it. And I'm going to copy again and paste it here, and if I click enter, it will ask me to authorize to Cloud Shell. Yes, I'm going to authorize, and as you can see, it's fetching the cluster endpoint and our data, the kubeconfig entry generated for the standard cluster from console. So this is how you can connect to the cluster. You can do the same for autopilot mode as well. So in this video we have played with GKE clusters, both autopilot and standard, and we learned how to connect to the cluster. You can also move to the observability, and you can observe your clusters here. You can also go to cost optimization and see the cost. You can see the CPU utilization and CPU hours. You can see here some data for both clusters. So this is how you can create GKE clusters and connect to the clusters. So in the next video, we are going to learn how to create a deployment and service in Google Kubernetes Engine. See you in the next video. In this video, before we create a deployment and service, I would like to take a look and understand about deployment and service with more in details. So what is actually deployment? Deployments represent a set of multiple identical pods with no unique identities. A deployment runs multiple replicas of your application and automatically replaces any instances that fail or become unresponsive. In this way, deployments help ensure that one or more instances of your application are available to serve user requests. Deployments are managed by the Kubernetes deployment controller. Deployments also use a pod template, which contains a specification for its pods. When a deployment's pod template is changed, new pods are automatically created one at a time. So in order to create a deployment in GKE, you can use the kubectl command. This is a Kubernetes specific command. Kubectl create deployment and the name of the deployment, and you have to specify the --image and you have to specify the image with a version. So in the next video, while we're creating a deployment, I'm going to explain it with more in details, and we'll see some examples. So now let's go to service. What is service? The idea of the service is to group a set of pod endpoints into a single resource. You can configure various ways to access the grouping. By default, you get a stable cluster IP address that clients inside the cluster can use to contact the pods in the service. A client sends a request to the stable IP address, and the request is routed to one of the pods in the service. A service identifies its member pods with a selector. For a pod to be a member of the service, the pod must have all of the labels specified in the selector. Basically, a label is an arbitrary key-value pair that is attached to an object. Now let's talk about why we use actually Kubernetes service. First and foremost, in a Kubernetes cluster, each pod has an internal IP address, but the pods in the deployment come and go, and their IP addresses change. So it doesn't make a sense to use a pod IP addresses directly. So with a service, you get a stable IP address with a stable IP address that lasts for the life of the service, even as the IP addresses of the member pods change. A service also provides load balancing. Clients call a single stable IP address, and the requests are balanced across the pods that are members of the service. Let's take a look of types of Kubernetes services. There are actually 5 types of services, including cluster IP, which is default, and it is where internal clients send requests to a stable internal IP address. The next is a node port, where clients send requests to the IP address of a node and one or more node port values that are specified by the service. The next is a load balancer. Clients send requests to the IP address of a network load balancer. Another type of the Kubernetes service is external name, where internal clients use the DNS name of a service as an alias for an external DNS name. The next one is a headless. You can use the headless service when you want a pod grouping but do not need a stable IP address. So these are the most essential, like the brief descriptions of these types of the services. If you want, you can go to the official Google Cloud documentation and read more about each type of the service and also deployment. This is all about it for this video. In the next video, we are going to create a deployment and service, so you will understand about these two concepts with more in details in the next videos. See you in the next video. As you remember, in our previous steps, we learned how to create GKE clusters in both autopilot and standard mode with default configuration, and also we learned how to connect to the clusters. In this hands-on lab, we are going to learn how to deploy microservice to the Kubernetes. To do that, we need to create deployment and service using kubectl command. Kubectl is a Kubernetes specific command line. So to create a deployment, we use kubectl create deployment. So for that, let's go and activate the Cloud Shell. And the first command we need to run is, as usual, we have to set the project, and I have already showed you. So we are going to start creating deployment. So we are going to run kubectl. So this is a Kubernetes specific command line. Create deployment. And after that, you have to specify the deployment name and the image. So I'm going to copy it from my another window, and here I'm going to paste it. Deployment, and let me copy again. Copy, and here paste it. And here, as you can see, I'm giving the name, and here is a typo. I'm going to add H. You can see that I'm giving, after kubectl create deployment, I'm giving the deployment name, which is Hello World REST API, and we are using the image in 28 min hello world REST API and the version 0.0.1 release. So stop the video and just don't make a typo, and copy it and click on enter. And as you can see, deployment.apps hello world REST API now created. So once we create a deployment, we can run command kubectl get deployment, kubectl get deployment. We can see the name of the deployment. You can see it's ready, and you can see it's up to date and it's available. You can also see the age. So we can also access to this deployment. To access to the deployment, we can run kubectl expose deployment hello world REST API. And after that, after you specify the name, you need to also mention the type. It will be load balancer, and you also need to specify the port --port, and port would be 8080. As you can see, we are running kubectl expose deployment hello world REST API. We are using the type and port. So let's click on enter. You can see service hello world REST API exposed. So when you expose deployment, what will happen? It will basically create Kubernetes service. To see the service, you can run kubectl get services. We can see the hello world REST API. You can see that it's the type load balancer, and we can see the cluster IP, but we don't see the external IP because it's in pending mode. But if we wait about like 10 or 20 seconds and again run kubectl get services, you'll also see the external IP. You can see the port and the age. So let's run again the kubectl get services to get the external IP. Now as you can see, we can see the external IP. So now what we can do, we can also watch the service by running kubectl get services watch. Basically to watch the service, you can run the command. First we need to write a curl, and after that we need to copy this external IP. Let me write again curl and the external IP. Let me clear this page so you cannot confuse it. Let me clear it. Let's run curl. Let's open the notepad. So the best way is to open the notepad, and here write the command curl, and after that you have to specify the external IP address, and after that we can write the 8080 port, and we need to also specify the hello world. Now what you can do, you can copy this, and here we can basically paste, and if you click on enter, you can see the hello world from version 1. You can see the random ID here. So we can also copy this. We can also copy this external IP and the port and hello world, and if you click on the new tab and paste it, you will see that it's showing me hello world v1 random ID message. So this is how you can create a deployment and service inside the GKE cluster. So I have to mention the fact that whenever you are working with clusters, we always use this gcloud command, gcloud. However, if you want to deploy microservice to the cluster, or if you want to expose microservice to the external world, you should always use kubectl command. Kubectl. This kubectl command is a Kubernetes specific service, so you can use it while you are deploying microservices to the cluster, while you are exposing microservices to the external world. So this is all about it for this video. See you in the next video. In this video, let's understand about pods and what is replica sets. So basically, pods are the smallest, most basic deployable objects in Kubernetes. A pod represents a single instance of a running process in your cluster. Pods contain one or more containers, such as Docker containers. When a pod runs multiple containers, the containers are managed as a single entity and share the pod's resources. Pod also contain network, storage, ports, volumes, which are shared persistent disk. You can also consider a pod to be a self-contained, isolated logical host that contains the systematic needs of the application it serves. So we are going to use some commands in the next video to get pods, how to get a pods, how to create a pods. So now let's talk about the replica set. What is replica set? When you deploy an application in GKE, you define how many replicas of the application you would like to run. When you scale an application, you increase or decrease the number of replicas. Replica set basically ensures that specific number of pods are running for a specific microservice version. You can use the command kubectl scale deployment and the name of the deployment, and you can use -- replicas, and if you can specify, for example, 2 replicas or 3 replicas. So this is all about it for this video. See you in the next video. In the next video we are going to scale deployment and resize the node pools. Hey everyone, let's continue our Kubernetes journey. In this video I'm going to show you how you can scale deployments and resize the node pools. So to increase the number of instances of your microservices, we can run the command kubectl scale deployment, and the name of the deployment hello world REST API. If we want to increase the number of instances, we need to specify the replicas. So these replicas will be instances, let's say 3 instances. And if you click on enter, you can see deployments.app hello world REST API scaled. So to see it, we can run kubectl get deployment. And as you can see now, hello world REST API has the 3 instances, and you can see it's up to date. So you can see these 3 instances, and each of these instances are called pod in Kubernetes. So if you do for example kubectl get pods, you can see we have a 3 pods. It's ready, but all of them. So all in all, Kubernetes provides scaling and load balancing in a very simple ways. We can also increase the number of nodes in our Kubernetes cluster. So for that we can run gcloud. Remember, we are using gcloud to play with clusters. So when we are playing with, we are deploying, or when we are, for example, scaling the deployment, we are using kubectl command. So I'm going to run gcloud container clusters resize. After resize, we have to specify the name of the cluster. Here you can see it's I'm going to scale resize the standard cluster, and I'm going to copy paste the name, and after that I will specify the node pool. You can see the node pool here. If you go to standard cluster from console, and if you go to nodes, you can see the default pool. So name of the node pool is default pool. I'm going to write after - node pool, I'm going to write default pool, and I have to specify the number of nodes, and let's make it 2, and we have also specify the zone. So in this case, zone would be, let me check it again. So you can see, if you go to details, you can see its zone is US Central 1C. So let's make US Central 1C. If we click on enter, You can see it's asking me to confirm it. I'm going to write yes and confirm it. You can see it's resizing the standard cluster. So this is how you can scale deployments and resize the node pools. So it will take some time to resize my cluster. So in the next video, we are going to learn how to auto scale the config map and secrets. See you in the next video. Welcome back everyone. In this hands-on lab, we are going to learn auto scaling, config map and secrets. So first we are going to start how to set up auto scaling for your microservice or your cluster. So to do that, we are going to run the command. So in order to set up auto scaling for your microservice or your cluster, we can run kubectl auto scale deployment, and the name of the deployment is hello world REST API, and we need to specify the max to 4, and we also need to specify the CPU percent. It's gonna be, let's say, 70. So as you can see, we are running the kubectl autoscale deployment hello world REST API. We are specifying the max 4 and CPU percent 70, and if you click on enter, you can see horizontal pod autoscaler dot autoscaling hello world REST API is created. So how does this autoscaling work internally? When I executed this kubectl autoscaler command, it created horizontal pod autoscaler. This is also called HPA. For example, if you run kubectl get HPA, you'll see the hello world REST API. You can see the deployment hello world REST API. You can see, you cannot see the CPU utilization, but you can see the 70%. You can see the mean pods and max pods. You can see the replicas. We have one minimum number of pods and maximum number of pods is 4. You can see the replicas. So this is how we can scale our microservice. Now, but what if you want to auto scale your Kubernetes cluster? So we are going to run gcloud, and after that we need to write container, gcloud container clusters update, and the name of the cluster, it's standard cluster from console. I don't know why we choose this long name, but let's say gcloud container clusters update the cluster, standard cluster, and we need to enable auto scaling, and we also need to specify the minimum number of nodes. Let's say minimum number of nodes are equal to 1, and the maximum number of nodes equal to not num but max nodes equal to 10, let's say. Here we also need to specify the minimum number of nodes. So what we are doing, we are running gcloud container clusters update standard cluster from console, the name of the standard cluster, and we are enabling auto scaling, and we are specifying the minimum number of nodes and maximum number of nodes. So this will auto scale your Kubernetes cluster. If you click on enter, it's showing that we need to specify the zone. Let's say zone US Central 1C, and if you click on enter, you can see it's updating standard cluster from console. See, I'm just forwarded my time because it took a lot of time to update the standard cluster from console, but it's done. You can see it's stated updated. It's giving me the link, and if I click this link, it's saying me an error because it's saying the request is missing required authentication credential. Because I'm using my QuickLabs account, it's giving me some errors, but hopefully in your GCP account, if you are doing the same steps with your GCP account, it will not give you an error. So now let's add some application configuration for your microservice, and you can do that by doing the config map. So let me clear this page, and we can do we can do kubectl create config map. So this config map will add some application configuration for your microservice. So kubectl create config map, and the name of the config map, for example, GCP learners, and let's say config. And after that, we need to specify the from literal, and we need to specify RDS DB and the name, let's say to-dos. And if you click on enter, you can see it's created the config map. So we can use this config map from our microservice. So we can run kubectl describe config map, kubectl describe config map, and the name of the config map is a GCP learners config map. If we click on enter, you can see I think we have a typo. Kubectl describe config map, it's a GCP learners config map. Let me do this. Kubectl get config map, and you can see it's a GCP learners config, not config map. So I'm going to go back and run the kubectl describe config map, and here I'm going to run GCP learners, not config map. We give the name config. If you click on enter, you can see the description, the name, for example, GCP learners config, and you can see the namespace default. You can see labels, intonation, and RDS DB name. You can see the to-dos. So in addition to this, we can also configure, and we can also store secrets like password. We can also store it in Kubernetes as a secret. For example, if we run kubectl create secret, let's say we will give name generic and name, let's say hello world secrets. And after that, we need to specify from literal RDS DB, no, password, and after that, let's say dummy to-dos. So we are running kubectl create secret generic hello world secrets, and we are specifying -- from literal RDS password, and we are specifying the password dummy to-dos. So this will basically store secrets like a password. As I said, you can store it Kubernetes as a secret. If you click on enter, you can see the secret hello world secrets created. So to see our secret, we can run kubectl get secret, and as you can see, it's hello world secrets. So we can also run kubectl describe secret and a name hello world secrets. If you click on enter, you can see the name hello world secret. You can see the list of description. So this is how you can autoscale deployment. This is how you can autoscale your Kubernetes cluster. This is how you can create a config map and secrets in Google Kubernetes Engine. Thank you very much, and see you in the next video. So far we have been playing with Google Kubernetes Engine, and we have seen lots of cases, and we have created GKE clusters. We learned how to create services, deployment, and others. So in this video, we are going to explore the deployment with YAML declarative, and we are going to see the other services of Google Kubernetes Engine. So if you go to workloads inside the Kubernetes Engine, you can see the overview. And inside the overview, you can see the name hello world REST API. And you can see the type, pods, namespaces, and cluster. If you click on this hello world REST API, you will see the list of information. You can see the overview. You can see, if you go to details, you will see it more clearly. You can see the cluster, and you can see the replicas. You can see the auto-scaling, horizontal pod auto-scaling. You can see the pod specification. You can also go to revision history and events, logs. You can also see the logs, the list of details. You can see the timestamp. So if we go to YAML, in this video I'm going to want to focus on YAML. So we have run several commands using the command line, but we can also create, we can also change we can also resize the number of replicas using the YAML. For example, you can see the kind deployment. You can see the list of information like labels, API version. You know, if you go below, you can see the spec. You can see the replicas. For example, we can also edit this YAML and change the configuration if you click on edit, and if we change, for example, the number of instances by changing the replicas, for example, from 2 to 3, if we click on save, you will see it will start updating. And if we go back, you can see hello world trace API, it's showing an error, doesn't have a minimum availability. Let's refresh it, and you can see it's turn it to green check, so it means it's working. So if we go back again to YAML, and if we go to spec, you can see the number of replicas change it from 2 to 3. So this is how you can change the configurations using the not only command line but also the YAML. And if you go to below, you can see the services and ingress. In services and ingress, you can see the services hello world trace API. You can see the type is external load balancer. We created it using the command line. You can also see the endpoint. If you click on this, you will see the healthy true, so it's working. You can also see the cluster. So if you go to ingress, we don't have any ingress, you can see. So if you come back to the services, you can see it's a description. Services are set of pods within a network endpoint that can be used for discovery and load balancing. However, ingresses are a collection of rules for routing external HTTPS traffic to services. So I would highly recommend to understand the differences between services and ingress. And you can also come to applications, and you can see here we don't have any applications. The Kubernetes application collect containers, services, and configuration that are managed together. You can basically deploy. You can come to secrets and config maps. Here you can see the GCP learners config that we created using the command line, and the secrets. We also created secrets, as you remember, hello world secrets. So here you can see it from the console. You can come to the storage, object browser, migrate. You can also migrate to containers. So let's give it time to update. You can see you can add the source and manage source. You can also see the backup for GKE. You can also configure the security posture, config, and policy. So let's come back. So all in all, we have played with GKE, the Google Kubernetes engine, in this crash video, in this crash section. So we can also delete the microservices and delete the clusters. So if you go to, for example, clusters, and then if you, for example, activate the Cloud Shell, you can also delete the cluster using the console. But I'm going to show you how you can delete the microservices or the cluster. So you can, for microservices, as you know, we run kubectl and delete, for example, service, or you can also delete, for example, deployment. And after the service or deployment, you need to specify the names. And you can also get, if you don't remember the service name or deployment name, you can basically run kubectl get service, or you can also write the kubectl describe the service, and you will get a list of information. We can also delete the cluster. As you remember, while we were working with cluster, we used the gcloud, not kubectl. For example, gcloud container clusters, and then you can delete, and you can specify the, for example, autopilot or the standard cluster. So thank you very much for this amazing Kubernetes journey, and see you in the next video.